Okay, let's continue our topic now, inverse functions. Let's look at example 3. Consider f. This notation means the original function f of x is 2x minus 3 over 3. In example 1, we have already reviewed two different methods to graph a linear function. The first method is we use the slope-intercept form. And the second method is we look for the x-intercept point and the y-intercept point and join these 2 points up to form a line. So you can use either of these 2 methods to graph this linear function. Here, I want to stick to the first method, which is the slope-intercept form method. So this is 2/3 x minus 1. You will see the y-intercept is -1. So this point is 0, -1. Slope 2/3 means you go up to right 3, up to right 3, up to right 3. So right now you have plenty points to join them up, and this line is the original function line. Okay. So right now we want to graph its inverse. If you want to graph its inverse, you can put on this y equals x line and then draw the reflection image. But of course, the best way is to use some points on the original function to help you graph the reflection image. If you switch 0 and the -1 around, the new point -1, 0 should be on the inverse function. This point is 3, 1. We switch these 2 coordinates around. This new point is 1, 3. Okay, this one is also on the inverse. You can get one more point. This point is 6, 3. Switch around. So that means the inverse path through 3, 6, which is here. So right now, use those 3 points. You can graph the inverse function. And let's change the inverse function to the red color. So the red line is the inverse function line. So question B, the question is asking me to use 2 different methods to find its inverse. The first method is math 10 method. If you know 2 points, you can find the line equation. The second method involves 2 steps. Step 1, interchange x and y. Step 2, solve for y. So we want to use math 10 method to confirm this new method is working for looking for the inverse functions. Okay, so let's look at the first method. Since you know the inverse function pass through 2 points already. One is -1, 0. The other one is 1, 3. With these 2 points, I can find the slope. The slope formula is y2 minus y1 over x2 minus x1. You can take one of these 2 points as x1, y1. Then the other point should be x2, y2. So here, my y2 is 3. My y1 is 0. My x2 is 1. My x1 is -1. So the slope of the inverse line is 3 over 2. That means my inverse function should look like y equals 3 over 2x plus b. So right now, I only need to look for this b value, which is also the y-intercept point. How can I find this y-intercept? I can plug either of these 2 points back to this equation. For example, I use the first point. I plug -1 in for x. It's 3 over 2 times -1 plus b. The y value is 0. Therefore, I can find the b value, which is also 3 over 2. So that means the inverse function is such a linear 3 over 2x plus 3 over 2. Okay, right now we wanna use the new method to look for the inverse and look for if the inverse is the same as this one. So here, step 1, interchange x and y in the original one. So it will be x equals 2/3 y minus 1. Step 2, solve for y. So x plus 1 equals 2/3 y. Then divide both sides by 2/3. So y is 3 over 2 brackets x plus 1. If you distribute 3 over 2 into the brackets, it's 3 over 2x plus 3 over 2. You will see these 2 equations are exactly the same. Okay, question number 3. Ask you guys to check that f inverse of x is x. F inverse of f of x is x. So here we will use this example to confirm this conclusion again. Let's look at the first one. F of f inverse x. We plug the inverse into the original function. So 2/3 times 3 over 2x plus 3 over 2 minus 1. Open the brackets. 2/3 times 3 over 2. This is 1. So 1x. 2/3 times 3 over 2, 1. Plus 1 minus 1, they cancel out. So it's really x. The second one is f inverse of f of x. We plug f of x into the inverse. So it's 3 over 2 times brackets 2/3 x minus 1 plus 3 over 2. Let's open the brackets here. 3 over 2 times 2/3, that's 1x, minus 3 over 2 times 1 is 3 over 2 plus 3 over 2. Cancel out these 2. It's still x. Okay. Here, through this example, we confirm the conclusion we drew in example 1 again. So right now, let's look at example 4. If you still remember what we did in example 2, you will realize all the parabolas on the real number system has no inverse. Because if you flip the parabola over y equals x line, you will find the new graph is not a function graph. So this is a reason if you read this question here, you will see this function is a quadratic function, which means the graph is a parabola. However, the domain is not all real numbers anymore. The domain is x is less than or equal to 3. We need to find its inverse. Through this question, we will know this quadratic function on this domain has its inverse. Anyway, let's use the graphing to help us set up some ideas first, let's look at this quadratic function first. This one is the vertex form, which means I can get to the vertex right away. So you draw the axes yourself and scale them properly. 1, 2, 3, 4, 5. Anyway, it's just a sketch. Okay, so 3, 1 vertex. If you want to get a more accurate graph, you can find some points on the domain to get to the y values. Then you can get more points. For example, x equals 2, you plug in, the y value is 2. So 2, 2. X is 1, you plug in, the y value is 5. So you will find that this part of the graph is only a half parabola. You do not have the other half. This half means it passed through the vertical line test. It also passed through the horizontal line test. That means this green part is a 1-to-1 function. If it's a 1-to-1 function, the inverse exists. Let's look at y from the graph. Okay, I still want to draw y equals x. Then you can draw the reflection image. But of course, if you have the trouble in drawing the reflection image, you can just switch around the points, the coordinates of the points of the original function. 3, 1 become 1, 3. 2, 2 is still 2, 2. 1, 5 becomes 5, 1. So here, if you connect those 3 blue points up, you will find the reflection image looks like that one. And you will find that this blue graph passed through the vertical line test. That means this blue part is a function graph. So from this example, we will know only 1-to-1 function has the inverse. Okay, so right now we want to find its inverse algebraically. Following 2 steps. Step 1, interchange x and y. Then solve for y. How can I solve for y? We learned the quadratic equation with perfect square form already. So I will move this 1 to the other side. If I want to solve y in this perfect square form, I square root both sides. But of course, when you square root both sides, make sure you still remember you put on plus and minus sign. From this algebraic method, you also will realize the original function has no inverse either. So how can you realize the original function has no inverse from this form? Because you will see from this form, you have 1x with plus and minus, you should have 2 y's. So the inverse is not a function. So right now, we need to think about a question. Which solution should we choose? Should we choose plus or minus? Okay, you look at this blue graph, you will see all the y values should be less than 3. So that means I will choose minus sign for the square root. So this inverse function is 3 minus square root of x minus 1. Okay, so right now, I want to put down the original function here and the inverse function on the right side. I want you guys find the domain and the range for both of these two functions. What is the domain for the original one? This one is given. X is less than or equal to 3. What is the range? Based on the graph, we can see the range is y is greater than or equal to 1. Let's look at what is the domain for the blue graph, which is the inverse function graph. So you will see and the y value is less than or equal to 3. And you will find that the domain of the original function becomes the range of the inverse. The range of the original function becomes the domain of the inverse. Why? Because when we look for the inverse, I switch x and y around. That means this y is the x in the original one, and this x is the original y. So this y is the original x, so domain becomes range. The x is the original y, so the range becomes the domain in the inverse. So here is the conclusion we have for two functions which are the inverse to each other. Original function and inverse function. We interchange x and y. We also interchange the domain and range as well. Okay. The last concept in this lesson is self-inverse function. What is a self-inverse function? Let's look at an example here. If f of x equals 1 over x, find its inverse function. Let's follow 2 steps to find its inverse. But I don't have y in this function. It's okay. What I will do is I change this f of x to y. Then I can follow the steps. Step 1, interchange x and y. So it becomes x equals 1 over y. Then solve for y. After you solve for y, you will find this y is equal to 1 over x. And you will find this inverse function is the same as original function. Like such a kind of function, I call this is a self-inverse function. If I graph this original function, you know this graph already. We learned this one in the rational function. So this one is a hyperbola. If you draw the line y equals x, you will find that this hyperbola is symmetrical about y equals x itself. So any function which has an inverse and whose graph is symmetrical about the line y equals x is a self-inverse function. Here is your homework.